Okay, let us discuss problem number 2.28. It says two thermally insulated vessels 1 and 2 are filled with air and connected by a short tube equipped with a valve. So we have two cylinders, insulated vessels. So let us say this is one vessel and you have another vessel. These vessels are thermally insulated. That is dq is equals to 0. So vessels are thermally insulated. Now let us call this vessel 1, this is vessel 2. They both contain air. And there is a valve in the middle. So there is a valve in the middle. Now question says the volume of the vessel, the volumes of the vessel, pressure and temperature in them are P1, V1, T1 and P2, V2, T2. So this side we have pressure is P1, volume is V1 and temperature is T1. This side pressure is P2, volume is V2 and temperature is T2. Find the air temperature and the pressure established after the valve is opened. So now question says initially this valve is closed. Now if I open this valve, now we have something like this. So valve is open. So in this case valve is open. Are you getting? So valve is open. In the previous case valve is closed. Now question says find the temperature and pressure established after the valve is open. So we have to find temperature. We have to find pressure. Now you see this whole system will contain same temperature and same pressure. Why? Because if the pressure this side is bigger than this side, so what will happen? Gas will go from this side to this side. And a time will come when both will have equal pressure. So in the whole system we will have same pressure. Let us say pressure is P. Also in the whole same system temperature will be same. If this side we have a higher temperature, this side lower temperature, so what will happen? The gas molecule will come this side, take heat, goes to this side. So molecule will keep going from this side to this side. A point will come when the equilibrium is reached. So now I know temperature is same in both vessels. Now what I can apply is, I can apply mole conservation. You see, initial number of mole should be equal to total number of mole because there is no leakage of mole, no leakage of gas. In this whole system, total number of mole initially is equal to total number of mole finally. So let us say this side we have mole is N1, this side we have mole is N2, and then finally I can calculate, let us say mole is N. What will the final volume, final volume for this system? V1 plus V2, because this is V1, this is V2. Now gas molecules are free to occupy either this or this. So this means gas molecules are free to occupy any part of this vessel. So if I apply mole conservation, that is the initial number of mole is N1 in this vessel and this is N2. So this should be total number of mole this time. And this is if I apply PV is equals to nRT. If I apply PV is equals to nRT, so N1 will be P1 V1 by R T1. Similarly, N2 will be P2 V2 by R T2. Now I can apply for N1 plus N2, that is N. So P is P, volume will be V1 plus V2. Number of mole is N and temperature is R, gas constant is R and temperature is T. So this time N will be P V1 plus V2 divided by RT. Are you getting? Now these are the three equations, this equation, this equation and this equation. I can plug in the mole conservation. So if I do this, I think all of you have copied this one. So I can copy here P1 V1 by RT1 plus P2 V2 by R T2. This is equals to P V1 plus V2 divided by R into T. Now R goes out, so we will have P1 V1 by T1 plus P2 V2 by T2 is equals to P into V1 plus V2 by T. So this is my equation number 1. I have two unknown P and T. So we have one equation. From where we will get the second equation? Can you think? Can anybody tell me from where I can get the second equation? Now the second equation we will get from internal energy conservation. That is, the initial total internal energy has to be the final total internal energy. So the second equation I am going to get is initial internal energy now this is internal energy, this equals to final internal energy. So let me write final internal energy. So initial internal energy is N into CV into T. Basically, I can find internal energy in terms of dt. There is some constant, so some constant will be basically cancelled from both sides. So I can write in terms of absolute internal energy. So N into CV into T. So N1 CV into T1 plus N2 into CV into T2. So this is the initial internal energy. Final internal energy, number of mole is N1 plus N2, gas constant is CV and temperature is T. So I can write N1 T1 plus N2 T2 is equals to N1 plus N2 into T. So from here I will get the T. T is nothing but N1 T1 plus N2 T2 divided by N1 plus N2. And N1 is nothing but P1 V1 by R1, P1 V1 by RT1. You getting? So you see, and T1 I can say N1 T1 is nothing but PV by R. So this is P1 V1 by R1, that is R. And this is equals to P2 V2 by R. And this is N1 is P1 V1 divided by RT1. So this is P1 V1 divided by RT1 plus P2 V2 by RT2. Are you getting? So R cancels out throughout. So now I can write final temperature will be P1 V1 plus P2 V2 divided by P1 V1 by T1 plus P2 V2 by T2. Are you getting or not? Now if you plug the value of T in equation, so this is my equation number 2. If you plug the value of T in equation 1, so from equation 1 you will have, so let us say equation 1. So I think all of you have copied this one. So equation 1 is P1 V1 by T1 plus P2 V2 by T2. This is equals to P V1 plus V2 by T. Now just I have solved for T. If you plug the value of T, you can get the value of pressure. Are you getting or not? You can solve yourself. So let me write P1 V1 by T1 plus P2 V2 by T2 is equals to P V1 plus V2 divided by T. So T is nothing but P1 V1 plus P2 V2, this divided by P1 V1 by T1 plus P2 V2 by T2, and if you solve for pressure you will get the value of pressure. So let me give you the answer, you do your own calculation. So pressure will come out to be P1 V1 plus P2 V2 divided by V1 plus V2. So you can do your own calculation, you will get the final answer for pressure is this. Can you do this one or not? I think you can do this one. This is simple. You see, this goes up and this term are same. So this clearly cancels out. So this term and this term same. This will go up. So this cancels out. So now you will have this term only remains here. So this will go this side. So you will have P1 B1 plus P2 B2, and this B1 plus B2 will come down. So we will get this answer. Are you getting or not? Okay, let us do the next problem. I think all of you have. This is a fairly easy problem. You have to apply only two things. The mole conservation, because there is no gas that is leaking from the system. And the second equation you have to apply the energy conservation, internal energy conservation. Initial total internal energy is equals to total final internal energy. Basically, internal energy is not only NCV_T1. If you remember in chemistry classes we have already discussed, total internal energy is given by some constant plus NCV_T1, and that's why we said absolute internal energy cannot be found. Now this constant is not easy to find this side, but this side will also, this constant will be here. Are you getting? So this constant is this side as well as this side both, and that's why this constant and this constant gets cancelled out, and so I can basically write this expression because constant gets cancelled. So even if I writing absolute internal energy with constant does not appear in the equation. If you want, you can also write the equation in terms of change in internal energy should be 0, because there is no change, there should be no change in internal energy because there is no heat that is coming into the system. Thermally insulated vessels, or there is no heat that is going out of the system. So thermally insulated system says internal energy has to be conserved. That is, change in internal energy is 0. So you can get the same equation. You can try yourself by using delta U is equals to 0. That is, change in internal energy is 0. So first system we will have N1C1, N1CV T1 minus T. For second T2 minus T. This is equals to final. So N1 this equals to 0 basically. If you simply apply, so if you write in terms of delta U is equals to 0, what you will write? If you want to write the same equation in terms of delta is equals to 0, you will write change in internal energy of system 1, vessel 1, that is N1 CV into T1 minus T. This is the change in internal energy of 1, plus change in internal energy of 2, that is N2 CV T2 minus T, and this should be equals to 0. Sorry. Are you getting or not? Or even if you want, you can write T1 minus T or T minus T. Here also T minus T2, because final minus initial concept is generally written. A change in final minus initial. So if you take T that side, you will have N1 CV T1 plus N2 CV T2, and this side goes N1 plus N2 CV into T. So this CV cancels out. So we will have N1 T1 plus N2 T2 is equals to N1 plus N2 into T. You see the same equation you are getting there also. N1 T1 plus N2 T2 is equals to N1 plus N2 into T. You see the same equation here you are getting. This equation. So there are two ways to write the same equation. You can either write change in internal energy 0, or you can write absolute internal energy with constant. Constant gets cancelled out. We'll discuss the next problem.